Today we continue on the next equation for hydrodynamic. Before that, we need to recall what you learned on the continuity equation. Normi eh? Ada normi ke? Ada ke normi kelas ni?
Ada doktor.
Okay. So Normi, what you understand on the continuity equation tu? Boleh ceritakan sikit? Mic you tak function, you pakai laptop ke pakai phone ni? Maybe later for next class tu, you kena on dua-dua. So you can speak using your phone. You boleh tengok daripada laptop. Okay, so next time saya akan tanya you balik lah. Nazril, what do you understand on the continuity equation? Nazril ada? Nazril? Anyone with Nazril? Mana Nazril ni? Tak apa, nanti kita get back to Nazril. Arif Ali. Yes, what you understand, a little bit what you can capture from the topic continuity equation tu. Okay, very good. So anyone yang dah cuba soalan tutorial? Satu ke, dua ke, can you share? Any question? Ada tak sesiapa yang buat? Maybe soalan kita dah buat satu, dua kan? Soalan 3 ke 4, ada tak yang cuba untuk buat? Up to question 5. Ada ke?
Ada doktor.
Thank you Husnia, bagus. So maybe Husnia boleh terangkan sikit ke? Or you can share to the group so we can discuss sikit sebelum kita go to energy equation and also Bernoulli equation.
Jalan kerja dalam grup ke doktor?
Boleh awak share?
Ya.
Okay, thank you. Oh banyak ni, kita pilih satu je soalan ni 4, yang ni 5. Okay, so kita tengok soalan 4 dulu. Baca sikit soalan. Soalan kata, figure question 4 show pipes 2 and pipe 3 is branching. So pipe 2 takes 30%. So of course pipe 3 is about 70% of the total discharge. what are the value of discharge and mean velocity in each pipe. So you need to find mean velocity untuk pipe 2 dengan pipe 3. Pipe 1 dia dah bagi velocity. And they need you to explain what happen if diameter of pipe 1 increased by 50%. How would this change the effects in the pipe 2 and pipe 3? Okay, so now saya share jawapan Husnia. Husnia dah check dengan jawapan belakang tak? Jawapan bawah.
Dah check dah.
Betul kan?
Dapat sama.
Okay, very good. So let's see together. So Q1, the first thing you need to do the equation, very good. So correct, Q1 is equals to Q2 plus Q3. And then you can do for Q1 sebab all informations are given. So the area is pi d squared over 4. So this is the Q discharge total. Okay, and then dia cakap Q2 adalah 30% from the total. So very good. Okay, after dapat the discharge, of course you can calculate the V2 because the area can be calculated using the diameter. Okay, so dia akan dapat velocity, so correct unit also. Okay, and then after you get the Q1 and Q2, you can determine what is the Q3. Using the Q3, you can calculate the V. Okay, very good. Okay, so dia dah tulis balik jawapan. Value of discharge in pipe 1, pipe 2 and pipe 3. Velocity in pipe 1, pipe 2, pipe 3. Okay, very good. Yang lagi satu option tu question 5 kan? Betul lah ni. Okay, so jawapan dia betul. Cuma you kena explain sikit. What happen if the pipe mana tadi soalan dia? The question asks what happen if the diameter of pipe 1 is increased by 50%. Okay, tapi dia punya discharge is maintained. Okay, of course the velocity akan jadi. Kalau pipe lagi besar, what happen to velocity? Decrease. Macam tu lah you explain. The pipe will be decreased when the velocity will be decreased after the pipe increasing by 50%. Okay, so what will this happen to velocity in pipe 2 and pipe 3? Of course dia kata discharge sama, 2 dan 3 sama, which is pecahan dia samalah. Tadi 30% dengan 70%. So second one dia kata pecahan dia sama, which is 50 dengan 50. Okay, what happens to velocity? You can imagine lah this one. Okay. So thank you very much Husnia and siapa yang jawab tadi. So let's see on the next topic, which is energy equation. Now I am sharing the notes. Nampak tak notes? Next class saya akan buat revision lah. So for today we still need to continue on the topic of week 9, which is still under hydrodynamics. So we use the same reference. You can refer to this one. Okay, and then today we continue 3.1.6, which is energy equations and Bernoulli equations. Okay, so from the energy equations, this energy equation akan follow Bernoulli punya concept. But we call it as energy equations that follow Bernoulli equation lah. jarang kita guna Bernoulli equations. Kita use energy equations, follow Bernoulli punya konsep. Okay, so the learning outcome of this topic, you must be explain what is Bernoulli principle and also the energy equation. And after that, evaluate the engineering fluid problems by applying both equations. Okay, so this is the conservations of energy. We already discussed on the energy previously, di mana energy tidak boleh dihapuskan. Dia hanya boleh ditransform kepada energi yang berlainan. So, for hydrodynamics, we only have 3 energy involved, which is potential energy, kinetic energy, and also pressure energy. Okay, sama juga potential energy ni, apa contoh potential energy yang you belajar on physics sebelum ni? Ingat lagi tak? Dekat mana berlaku potential energy? Dia punya situation. Kalau kinetic, bila start moving. Okay, bila start moving je mesti ada kinetic energy. Pressure energy happen bila ada perubahan ketinggian, elevation. What is potential energy? Anyone?
Tenaga keupayaan, Doktor.
Betul, tenaga keupayaan sama juga dia melibatkan ketinggian. Bila tank berada pada suatu ketinggian, so dia melibatkan potential energy nak turunkan air daripada kawasan yang tinggi ke kawasan yang rendah. Okay, so that's why the energy involved in the pipeline ni kita ada potential, kinetic and also pressure. So we can see from the picture here, this is the stream tube. So the blue color is considered as the cross-section area. So it's moved from B to the change of B with the velocity B. Okay, so we have point B change to point B, point A will be changed to point A. So this fluid ada juga mg, ada weight, and that is elevation for this stream tube. Okay, and then we have also the datum levels where this is the highest and the lowest part of the pipeline. Okay, let's see one by one on the potential energy, kinetic energy and pressure energy. So potential energy is present by PE. PE ialah weight darab dengan Z. Weight ialah mg tadi. Z is dia punya ketinggian. Ketinggian from the datum. Okay. So kinetic energy is represented by Ke. So kinetic energy involve mass and also velocity. It is mass times velocity squared divided by 2. Okay, so this mass for kinetic energy will be represented by weight bahagi gravity. Sebab sebelum ni kita dapat weight equals to mg. So when we need to use the mass, the weight will be divided into gravity. Okay, and it also can be write as weight v squared over 2g. Okay, either one. You choose to change to mass ataupun you can use the weight but you need to put the g divided into g. Okay, that is for kinetic energy. Kinetic energy berlaku apabila fluid tu start bergerak. Okay, so next we have pressure energy. It represent by Fe sebab sama kan PE. So we change the abjad kat sini as Fe for pressure energy. So pressure energy is the amount of work needed to move from one point to another point. So we have density times area times D, change. So area times D, D ialah dia punya jarak, distance. So A dengan D ni is dia punya volume. Okay, volume also can represent by weight bahagi dengan specific gravity. So ini adalah, specific weight. So ingat lagi formula specific weight kita ada dua, rho G ataupun weight over volume. Okay, so now we need to determine the volume. Volume is weight bahagi specific weight. Okay, substitute the AD as V. So it is weight over specific weight. So you have density. Sorry, sekejap FE ialah force. Sorry, this one bukan density ya. So if you still remember the formula for pressure, apa formula pressure? Force over area. Kan? So now we need to find the FE, pressure, force. So it is pressure times area. When it's turned, we change to, we need to consider as the movement that change. So this area akan jadi volume. So this is pressure, this P is pressure times the weight over specific weight. Specific weight ni dia tukar jadi density times gravity. Okay, so this one you tak payah ingat lagi because this is the first introductions of the energy. Later, bila kita dah combine the total energy, that one you need to remember the derivations of formula after we combine all the energy. Okay, this is only the standard formula when we want to find the potential energy, Wz. Okay, so we move to this one. This is the thing that you need to remember. The first one is just the derivations, how we get this final formula. Okay, so this is the total energy. We need to combine the pressure energy, potential energy, and also kinetic energy. So this is the basic formula to find those energy. We have the weight plus Z, weight V squared over 2G plus pressure W divided by density times G. So we need to simplify. All will be divided by W, so we can cancel all the W. So finally, potential energy is represented by Z only. There's the elevation. For kinetic energy, we use V squared over 2G. For potential energy, it is pressure divided by density times gravity. Okay, so H here is represent total energy in terms of head. So if you still remember, you learn head dekat topik pressure, it is a unit meter. Okay, semua ni kenapa kita bahagi dengan rho G 2G ni, because we need to convert the kilopascal into the meter, in terms of meter. So pressure ni dia punya unit mungkin pascal atau newton per meter square. So when we divide to rho G, it's become meter, in meter. Okay, sama juga. The second one is in meter. Elevations of course in meter. Okay, you can see here all must be in the same unit, then only we can calculate the total energy. Okay, so part untuk total energy ni ada soalan tak? Dia tak faham ke? Okay ke?
Tak ada doktor.
Okay, so yang ni tadi tak
Dah
payah
tu.
ingat sangat. So this is the formula that you need to remember. or total energy head. Okay, a little bit on the explanations for static, dynamic, and also the stagnation pressure. So the kinetic and also potential energy in the fluid can be converted to flow energy during the flow. Okay, bila kita dah convert kepada flow energy, it causing the pressure to change. Okay, sebab dia dah berubah keadaan, berubah tempat, so it can cause the pressure to change by multiplying the Bernoulli equation by the density gives. Okay, so we have the first one is represent the pressure energy. Ini tadi dalam unit kilopascal lah, sebab dia tak bahagi dengan rho G. Okay, and then dia kata in respect to density. So here we have density. This one is represent kinetic energy. Okay, and then we have Z for elevation. Okay, P is the static pressure in kilopascal. It does not incorporate in any dynamic effect. It represents the actual thermodynamic pressure inside the fluid. Okay, this static pressure is the same as the pressure used in the thermodynamics and property table. Okay, maksud kat sini, P here, we are using the concept of static pressure. Okay, and then kinetic formula is represented by dynamic pressure. This dynamic pressure represents the pressure rise when the fluid in motion is brought to a stop isentropically. Okay, dynamic pressure involve pressure yang meningkat, increase of pressure or pressure change bila fluid bergerak dan mungkin dia akan stop because of the decrease in energy. Okay, and then another part is the potential energy, which represent the hydrostatic pressure. These types of pressure, not pressure in real sense, since the value is depends on the reference level selected. Okay, and we need to count the elevation effects, the Z. Examples ialah fluid weight on pressure, where the hydrostatic pressure, where sebelum ni you calculate hydrostatic pressure as rho GH. This rho GH increase with fluid depth H. So in this hydrostatic pressure, the H here is represent in terms of Z. So konsep dia sama lah. So rho GZ ni adalah represent potential energy, which is also same as hydrostatic pressure. Cuma in terms of hydrostatic pressure, kita tak tulis rho GH. We change the depth into Z as elevation. Okay, so for this one, sama je, total energy or total pressure is the sum of static, represent pressure energy, dynamic, represent kinetic energy just now, and the hydrostatic pressure is actually represent the potential energy. Okay, therefore the Bernoulli equation states that the total pressure along a streamline is constant. Okay, so masuk kat sini, baru kita go to Bernoulli equation. So Bernoulli equation adalah total head entering equals to total head out. Okay, so energy equation adalah yang total satu-satu tadi. This energy equation follow Bernoulli punya equation, Bernoulli punya principle, where the total pressure along a streamline entering sama juga dengan out. Okay, sama dengan continuity equation sebelum ni. Q in equals to Q out. So now head energy, head pressure in equals to head pressure out. So this one will be follow Bernoulli equation equals to H out. Apa maksud dia? That the energy cannot be created nor destroyed. The energy can only be transformed from one form to another form, which is kinetic. Energy ni je, tak boleh tukar lah kepada light ke tak adalah. So we have potential energy and also pressure energy. Okay. So Bernoulli equations also state that it is an ideal fluid. Apa maksud ideal fluid? It means that there is no viscosity. Kita abaikan dia punya viscosity sebab dia ideal. And the total energy within a moving fluid must remain constant. Okay, maksud kat sini, there is no loss of energy dekat setiap tempat ni. Okay, total energy dia akan remain constant. Bila kita consider as ideal fluid, maksud dia, dia tak ada viscosity, iaitu viscosity sebelum ni you belajar it is a friction. Bila fluid bergerak, dia akan berlaku drag of friction. Dia menyebabkan geseran, so lambat. So bila kita consider ideal fluid, maksudnya kita abaikan dia punya viscosity, kita abaikan dia punya friction loss. Sama juga dengan energy. So when it's considered ideal fluid, there is no energy losses during the transformations of energy. Okay, so the total energy at a point in a steady flow must be equal to the total energy at any other point in the path of flow, provided no energy is added, tak ada energy ditambah, ataupun tak ada energy that taken from it. So this is mean that no energy losses or energy add. Okay, no energy loss and also additional energy. Okay, so untuk Bernoulli equation ni boleh follow tak?
Boleh doktor.
Okay, boleh kan? Kalau tak boleh beritahu Okay, so that's what I mean on the Bernoulli principle. So it's between 2 point 1 and point 2. So the head 1 total energy equals to total energy at point 2. So total energy is include, this is the pressure energy. Pressure tadi FE kan? Pressure tadi FE kan? Pressure FE. Okay, so this is FE, this is kinetic, and this is potential energy. Okay, so this, the first part is referring to point 1. It has their own velocity and also own elevations from the datum. Okay, pressure at point 2 is represented by here, point 2. So they have their own potential energy, kinetic energy, and also pressure energy. Okay, so ni samalah assumption ni maksudnya follow Bernoulli equation. So kat sini velocity on the flow cross section is uniform, sama. Average velocity is used. So we use average velocity dekat point 1 dengan point 2. Effect of viscosity are very small compared to the gravitational forces. So there are no losses of energy due to friction. Tak ada any losses during geseran. And the energy of flow is not converted into other form. It only involves kinetic, potential, and also pressure. Tak ada heat energy, what other type of energy tak ada involved in this one. We only have kinetic, potential, and pressure. Okay. So let's see on the correction factor. So actually the kinetic energy, we need the correction factor sometimes. So how it being conducted? So we have actual velocity of fluid that depends on the position from the solid boundary. So if you still remember, kita ada solid boundary. So velocity of the fluid depends on the solid boundary. Semakin jauh daripada solid boundary, semakin tinggi velocity. So bila dekat dengan solid boundary, their velocity tend to follow the velocity of the boundary, which is 0. Boundary tidak bergerak. Okay, however, in deriving Bernoulli equation, the average velocity was used. Okay, tadi semakin jauh, semakin tinggi velocity. Tapi bila kita follow Bernoulli equation, we consider the average velocity. Kita dah tambahkan jadi average. So throughout the path ni, sampai ke sini, velocity dia remain constant. Okay, because we are using the average velocity for all the path. Kita guna average velocity. That's why it can consider as actual ataupun constant. Okay, therefore a correction must be made by introducing the kinetic energy correction factor. Okay, so let's see how the correction factor will be integrating. So here we have a small elemental fluid mass. dm is represent change of mass from the moving with velocity v. So through kinetic energy as given by this formula. Okay, dia ada m. Sebelum ni you learn kinetic punya formula adalah v squared over 2g. So when we need to do a correction, we need to consider the fluid mass. Okay, so we have a mass flow rate. Ingat lagi what is formula for mass flow rate? Apa formula mass flow rate? Mass darab flow rate, volumetric flow rate. Okay, this capital M is represented by mass darab volumetric flow rate. Okay, so we integrate this one so that we can calculate the total KE. Okay, so finally kita akan dapat nilai correction factor ni. If it is 1, it considered as uniform. When it is between 1 and 1.5, turbulent. More than 1 ni considered as laminar 2. Okay. So, however, this kinetic energy correction factor are often ignored. Okay. Maksud ignore ni adalah the correction factor is set equal to 1 in an elementary analysis. Okay. Boleh maksud dia kita nak bagi tahu there is a kinetic energy correction yang melibatkan velocity. When we use average velocity, sebenarnya dia ada we need a kinetic energy correction. Tapi bila kita study on elemental between that follow Bernoulli equation, we always ignore the correction. Apa maksud ignore ni? Kita dah standardkan dia 1. So semua flow adalah uniform. Okay. Okay, so setakat ni boleh follow tak? Yang penting tadi adalah energy equation satu-satu tu dan Bernoulli principle. Okay, boleh ya?
Okey doktor. Bernoulli principle. Okey.
Okay. So saya teruskan sikit je lagi. So here, tadi saya mention dia tak ada energy losses and energy gain. Okay, that is for macam ni. Dia kena ikut condition juga. Kadang-kadang soalan dia akan bagi juga energy losses. Okay, what means by that one? Energy losses ni, maksud yang tadi, energy losses dia tak berlaku dekat setiap part. Okay, kita akan calculate overall at the end of the part. So you can see here, semua kat bahagian belakang. Okay, that's mean by that one tadi. There is no energy losses for each part, for each kinetic, pressure, potential. Okay, but there is a total energy losses at the end of the calculation. Okay, so in practice, tadi you nampak ideal fluid kan? Ideal ataupun real. Okay, so here it referring to, dia guna perkataan real, sama je. Okay, ideal fluid or real fluid, no viscosity. There will be friction within the flow, which cause the energy losses. So energy losses can be incorporated as this one. So kita akan calculate energy losses dekat out. This is head out. Head up equals to head in kan. So we calculated at out. This one ada difference sikit sebab kita calculate kat belakang. So bila loss tambah. Dia terbalik. Loss patutnya tolak. Tapi loss kan kat in. Bila kita bawa daripada in ni kepada out, dia jadi tambah. Okay, so losses ada dua sebab. Ada dua faktor. Sama ada daripada pipe atau daripada turbine. Okay, maksud pipe ni adalah perubahan size pipe. So basically bila pipe tu daripada kita nak tukar pipe kecil kepada pipe besar kepada pipe kecil, nak branchkan dia, there is energy losses from the different change of pipe tu. So that energy losses is represented by HL. Okay, HT is the energy losses purposely caused by the turbine. Okay, so bila ada energy gain, so contoh along the pipe tu dekat tengah-tengah kita ada supply pump. So, dia akan bagi tahulah pump tu dekat mana, in center of the pipe ke. So bila ada supply of the pump, bila kita letak pump, the flow akan dapat energy. So it is minus. Okay, so terbaliklah, losses tambah, energy gain minus. Okay, this is the explanations on the energy. You can read this one later. Okay, so apa yang saya ceritakan tadi, it also can be represent as the design. So basically, you kena belajarlah how to read the design. This is the design of the reservoir. So from this design, they provide all the informations on the total energy line, TEL. So kita ada total energy line. Yang atas ni, yang not dotted. So you boleh baca lah daripada sini, point A kepada point B, the energy turun. Kemudian point B kepada C turun lagi. Okay, this is the graph how you understand on the energy. Energy decreasing ataupun energy increasing. Okay, and then this design also provide the hydraulic grade line, HCG. It is the represent the elevation plus the pressure head. Okay, yang dotted line ni represent hydraulic grade line. Okay, so dia represent elevation. Okay, another part, you can see here, there is a losses daripada tank nak pindah kepada pipe. So kat kawasan ni ada losses. Okay, inside the, dekat sini tak ada air bergerak. Air kat sini tak bergerak. So velocity dia zero. So bila velocity zero, tak adalah friction loss. So friction loss ni hanya berlaku apabila water bergerak. So dekat sini ada friction loss. Here, HF. Dekat sini pun ada friction loss sebab the water start moving. So here the pump means energy added. Okay, so we have minus this energy is represented by HP. Okay, so we also have the exit loss, HL. Kat sini dia dia details out what type of loss. Kat sini ada friction loss, there is a contraction loss sebab pipe besar menjadi pipe kecil. Okay, bila pipe besar, pipe kecil kepada pipe besar, we have enlargement loss. Okay, from this design schematic diagram, they provide all the information lah. So they have the U ni adalah kinetic formula. Tadi kita guna V kan? But this one dia guna U. Sama lah velocity. Okay, we have velocity here. This one also we can calculate the velocity. Okay. Same goes as this one. There are dua line which is total energy line and also hydraulic gradient. Flow velocity represent by U. Okay, kemudian dia ada tunjuk apex of pipeline, paling tinggi lah, point pipe yang paling tinggi. So yang tertinggi ni basically datum, sama lah. Paling bawah ada datum, paling atas ada datum. Okay. So untuk your question tak ada graphical ni tak adalah. Just to let you know that this design can be represented into a graph. Okay, we go through one example. This is a pipe conveying water tappers. Given that the cross-sectional area is 0.5 at A and 0.2 at B. So this pressure, this one need to convert into meter lah. That's why we use pressure divided by rho g. And the velocity is 2. Okay, this 2 is for kinetic energy punya calculation. So we assuming there is no energy losses because it is a real fluid ataupun ideal fluid. Determine the pressure at point B, which is 4 meter above the level of A. Okay, so this 4 meter adalah potential energy, Z. Okay, just write down the Bernoulli punya principle, which is head A equals to head B. So using the total energy equation, we have potential energy, kinetic energy, and also pressure energy. So ZA is considered as datum, 0. ZB is the elevations from point A to point B, 4 meter. So it is positive sebab dia located above the datum. So macam pipeline tadi kita dah consider as datum macam ni. So point kat sini dia akan jadi negatif. So contoh kat sini 6. So bila kita calculate elevation is negative 6. Okay, because it is below datum. Okay, so first kita dah list down kat sini. Area dah bagi. Pressure ada untuk A, B tak ada pressure. V pun ada untuk A. Okay, V untuk B tak ada. Okay, so first before we do the Bernoulli equation, kita kena buat dulu continuity equation. Kenapa? We need to find the V. VB. Okay, sebab dalam energy equation ni kita ada kinetic. So kalau kita tak tahu VB, how we need to calculate the kinetic energy. So first do the continuity equations to get the VB. And then boleh substitute into the Bernoulli principle energy equation. So masukkanlah ni adalah 120 kilopascal need to convert to pascal. So it is 10 kuasa 3. Ini adalah rho times G. So 1000 kali 9.81 dapat 9810. So the first V is 2. Okay, and then the elevation's potential energy ialah 0. The second velocity B is 5. Okay, so we have only one unknown here. So we can know the PB. Okay, PB ni in unit kilopascal. Okay. Soalan ni okey? Boleh tak?
Setakat ni boleh, doktor.
Okay, so kalau tak boleh, you boleh go through again lah this video. Kat YouTube pun saya ada provide on that. Boleh kot lagi satu soalan. Later we continue on next class. Okay, so lagi satu soalan. A siphon has a uniform circular section of 7 mm diameter. So maksud dia pipe ni sama size, 70 mm. Okay, so it consists a band pipe with a crest of 1.6 above the water level. The siphon discharge into the atmosphere at level 3, below the water level. Okay, so what you need to understand first adalah dekat A ni velocity dia 0. Okay, sebab there is no movement of water. Okay, and then dia bagi tahu discharge kat sini. Discharge into the atmosphere. Okay, bila discharge into the atmosphere, maksud dia pressure is 0. Okay, discharge from atmosphere dengan to the atmosphere, it cause the pressure 0. Okay, and then the question asks us to calculate the velocity and the discharge. This one is referring to velocity kat B dengan C lah. Sebab we know that velocity for A is 0. Okay, and then given that the absolute pressure head at the end of the siphon is equivalent to 10 meter head of the water. So we need to neglect all the losses. So tak ada losses lah due to the ideal fluid. Okay, so this 10 meter is already referring to pressure head. So the pressure tak perlu lagi bahagi dengan rho G. We don't need to divide. We just use the pressure as 10 meter sebab they already in unit meter. Okay, so let's see how we calculate. So this is the assumption that we need to make first. Velocity is taken 0. Okay, so sama juga. The pressure is coming from the atmosphere. So it is considered 0. Pressure from atmosphere and out to atmosphere is 0. 0. So it is considered as datum. So we have the datum at A and also datum at C. Okay, now we have the point B is at the crest. Velocity is not 0 because the water is moving. And the pressure is also not 0 because it is not the atmospheric pressure. Okay, this part you need to understand first. Kita akan cancel dulu part yang 0. Okay, so we do the Bernoulli equations. So kita consider lah PA dengan PC is 0, can cancel. ZA adalah 0, datum. VA 0 sebab dia dekat dalam tank, tak bergerak. Okay, ni kita compare HA dengan HC. We do compare A dengan C dulu. Kenapa kita buat A dengan C dulu? Sebab C ni dia dah ada information sikit. B langsung tak ada. Okay, C ni kita dah tahu pressure dia 0. Dan we have the nilai kat sini. So we do for C dengan A dulu. So the elevations is located below the datum. So it is -3. So yang tinggal adalah VC squared dengan ZC. Okay, so kita substitute lah nilai VC. VC adalah 7.672. Mana dia dapat 7.672? Dia calculate. Siphon discharge. That is -3. Okay, so this one VC is unknown. This one is 2 darab 9.81. Okay, so we bring the 3 here. So we can know the VC. Okay, VC is square root 2, baru dapat nilai 7.672. Okay, so kita boleh consider velocity dia sama sebab dia cakap diameter throughout the pipe ni sama. We have the uniform circular section. Okay, that's why VB sama dengan VC sama dengan V. So then we can calculate the discharge using the continuity equations AV. The diameter is 0.07. Okay, so we already know the discharge of the discharge flow. Dia minta discharge. So have to calculate. Okay, and then next we compare head point A dengan point B. So from the considerations ni kita boleh cancel pressure, velocity and also elevation. Okay, this is for point A, di mana air tak bergerak dalam tank. So semua tak ada. Okay, and then for point B, semua adalah tak ada pressure. We have the kinetic and also the elevations is above the data. So tambah. Okay, so velocity tadi sama, 7.672. Pressure dia, we can calculate in kilopascal. Okay, and then when we calculate the pressure at point B, we need to consider we calculate the absolute pressure. So absolute pressure adalah P atmosphere tambah dengan gauge pressure. So this 10 meter converting into kilopascal, then only baru kita boleh add. Okay. So kita tambah atmospheric pressure dengan gauge pressure, so we get the absolute pressure for point B. Boleh? Boleh tak?
Boleh doktor.
Okay, so saya takut banyak sangat you tepu. So I think I stop here. So another examples kita akan go through on next class. Okay, however you can saya dah ajar dah all. Only the trick of the question je you all tak belajar lagi. So you can try lah. Okay, you can try answer this one. Later saya akan explain juga. Okay, thank you very much. So saya nak remind sebab ada yang silap. Awal-awal SEM dulu saya cakap quiz pada hari Rabu. Sebenarnya kita dah tukar ke hari Sabtu. So your quiz is hari Sabtu pukul 9 pagi, 18 hari bulan. Boleh? Sebab saya tak nak ada lagi yang tanya lecturer lain hari Rabu ke macam tu. Okay, takut kawan-kawan awak confused. So the exam is on Saturday pukul 9 pagi. Boleh?
Baik doktor.
Okay, good. Boleh do your revisions and tanya saya. Saya dah provide dah soalan-soalan past quiz dekat U-Future. If you can find out. Okay, so adalah soalan quiz, soalan test, semua ada kat dalam U-Future. Okay, that's all for today. Thank you very much. Bye.
Thank you, Dr.
Thank you,
Doktor.
Doctor.
Thank you doktor.
Welcome.
Thank you, Doctor.
Thank you, Doktor.
Thank you doktor.
Welcome.